When you hear emergency preparedness plan, what do you picture?
Probably a binder on a shelf, right?
Exactly, a binder, collecting dust. And we breathe a little sigh of relief thinking, okay, great, there's a system.
Mm-hmm.
But knowing there's a plan is, it's miles away from knowing the exact minute-by-minute life-saving steps of that plan.
And that's the difference. That precision is everything, especially when you're managing a massive, complex industrial site like this Rhino project.
It's huge.
It's huge, and it's complicated. You've got two totally different high-risk environments in one place. You have heavy manufacturing in a factory,
Right.
and then you have active, constantly changing construction zones.
Right.
That kind of complexity, it demands a protocol that leaves absolutely no room for
Yes.
interpretation when seconds literally count.
And that's exactly what we're digging into today. We have the source material, the Rhino Project Emergency Response and Safety Protocol, and this isn't theoretical stuff.
No, this is an operational blueprint.
It details the systems, who's responsible for what, and the procedures that cover, everything from a minor chemical spill to these incredibly complex, specialized rescues.
So our mission in this deep dive is to synthesize that really dense, detailed system into actionable knowledge for you.
Yeah.
Because whether you work in an office tower or a refinery, understanding how this is structured gives you a blueprint for effective emergency management in any complex environment. It forces you to look past just having a phone number.
And focused on the structure.
The clear structure, the redundancy, and the immediate action.
Okay, let's unpack this. So let's start with the absolute basics, the first few seconds of an incident.
Right.
The protocol immediately tries to remove that decision paralysis. It doesn't rely on people fumbling with their phones or
Googling numbers in a panic.
Exactly. The plan mandates that the primary emergency contacts, we're talking the site hotline, ambulance, fire, the safety officer, project manager,
Our
security,
key players.
all of them, they have to be visible on everyone's ID badge and posted at all the workstations.
It's a move designed for zero friction. When adrenaline spikes, your memory just fails.
Of course.
So having that info physically there, right where you need it, is just that first crucial layer of redundancy. And from there, it transitions right into the medical logistics, which are fascinating because they're not one size fits all.
No, they're completely tailored to the two different environments.
Totally.
So in the permanent factory area, you have a fixed, dedicated first aid room. And this thing is, it's stocked like a small clinic. It's got an AED, a stretcher, oxygen.
And it's staffed, right, during all operational hours.
Always staffed. But then you go over to the construction site, and that needs to be flexible because the danger zone changes every single day.
So they use a mobile medical unit.
A mobile unit. And these strategically placed first aid stations, with the green cross signs.
Mm-hmm. And with construction, you've got different hazards, so there's a specific rule about emergency eye wash and shower stations near any chemical storage or battery charging areas.
It's just smart. Different risks need different infrastructure. The protocol makes sure the equipment moves with the risk.
And once that internal system kicks in, you hit those critical minutes where you need outside help, like an ambulance.
Right. And this is where site logistics become the difference between a minor delay and a catastrophe.
What's fascinating here is how the procedure moves from just assessing the situation to actually controlling how external help gets in. First, obviously, the internal team makes sure the scene is safe, checks consciousness, and they have that rule. Do not move the injured person unless they're in immediate danger.
A standard but critical first step.
Absolutely.
Okay.
But then comes the logistical choreography. This site is enormous.
You can't have an ambulance just, wandering around trying to find the right building.
No way. The source dedicates a whole section to defining these precise, designated ambulance access routes that have to be kept clear. Always.
And they specify the entry points. Gate A for the factory, Gate C for construction.
Yes.
So why is that distinction, Gate A versus Gate C? Why is that so important? Why not just use the closest one?
Because that simple detail saves 5 minutes of wasted time. 5 minutes of driving past loading docks or heavy equipment.
Ah.
If it's a factory incident, Gate A, security is pre-briefed to meet them there and take the fastest, clearest route to that fixed first aid room. If it's construction, Gate C, they have a different route designed for maybe rougher terrain or temporary road closures to get to the mobile unit.
And someone has to meet them.
The protocol mandates it. A site representative must meet the ambulance at that designated gate. It's pre-planned choreography to shave off critical time.
Here's where it gets really interesting. Okay, let's shift from medical logistics to fire and evacuation. That requires a completely different kind of rapid, standardized response.
Mm.
So when that alarm sounds, the protocol outlines a really clear universal progression. The evacuation routes are marked with green illuminated signs, and there's that universal rule. Never use elevators.
Never.
Everyone proceeds to a designated assembly point north parking lot for the factory, or these zone-specific points for construction. And it's not over until every single person is accounted for.
And the fire response details, that's where personal judgment meets a really rigid protocol. After you sound the alarm and call for help, the source lays out this 2-minute rule.
That 2-minute rule, it always sounds so, I don't know, so harsh. Why 2 minutes specifically? What's the biggest risk if you go past that?
The risk is fire growth.
Yeah.
I mean, it's exponential.
Okay.
Most small fires, if you catch them right away, you can probably handle them with a portable extinguisher.
Mm-hmm.
But the data shows that after that 2-minute mark,
Mm-hmm.
that's when a small contained fire can just explode into a major structural hazard.
Creating overwhelming smoke and heat.
Exactly. Blocking exits, escalating the danger for everyone, including the person trying to be a hero. So you're only allowed to try and fight it if you're trained, and only if you can control it within that 2-minute window. If not,
You get out.
you get out immediately.
Yeah.
Non-negotiable. And you close doors behind you to contain the spread. That 2-minute clock prevents heroes from becoming casualties.
And if you do decide to fight it, this is where you have to know your stuff. You can't just grab any extinguisher.
Oh, no.
You have to know the color code. This is, I think, a perfect learning nugget for anyone, anywhere.
Absolutely. Because using the wrong one can turn a bad situation into an explosion or an electrocution risk. You have to be precise.
Okay, let's run through them. Red extinguishers.
Red is water, Class A materials only. Wood, paper, textiles. Your basic combustibles.
Then you have blue. That's powder.
Blue is your multi-purpose tool. It'll handle Class A, B, and C fires. So, solids, flammable liquids, and electrical. It's versatile, but it's very messy.
And you have to know that black means CO2.
And this one is critical. Black CO2 is for Class B, flammable liquids, and E, electrical fires. And that's crucial because if you hit an electrical fire with a red water extinguisher,
You're in big trouble.
you're essentially electrocuting yourself. CO2 and powder are non-conductive. That's the key.
And finally, cream. Cream is foam.
Cream foam is for Class A and B. Again, really good on flammable liquids where you need to smother the surface.
What's fascinating here is it's the sheer level of technical specificity. They're basically teaching a crash course in fire science to every single employee.
They have to.
Okay, moving on to specialized hazards. The procedures for chemical spills, they're also split dramatically based on, size and severity.
Precisely. For a minor spill, the steps are pretty contained. You put on your PPE, you find the nearest spill kit, contain the mess, and report it to your supervisor.
An internal cleanup.
Right. It's focused on control.
Right.
But a major spill,
Mm-hmm.
that triggers an immediate site-wide escalation.
So immediate evacuation of that area, sound the alarm, call outside emergency services, set up a perimeter.
And here's the critical step. The people on site must instantly provide the first responders with the SDS.
The SDS, the safety data sheet. If I'm a first responder showing up, I need to know exactly what I'm walking into.
You have to. The SDS tells you the chemical's identity, its hazards, what PPE to wear, ventilation needs, and most importantly, the right first aid and cleanup procedures.
It's the difference between bringing a water truck and a full-on neutralization team.
Exactly. And the protocol is clear. Only a trained HAMAT team handles major spills, period.
The source also gets into these really high-stakes dangers from heavy machinery and electrical systems. For an electrical emergency, the absolute rule is it's simple, but panic makes people forget it.
Do not touch the victim if they're still connected.
Right. You have to shut off the power at the main breaker if it's safe. If not, you have to use something non-conductive, a wooden pole, heavy plastic, to separate them from the source.
It emphasizes self-preservation first. A second victim doesn't help the first one.
And maybe one of the most sobering details from the construction site part of the protocol is about working at heights. And we're not just talking about the fall itself, but what happens after a fall when a worker is caught by their harness.
Suspension trauma.
Suspension trauma. The protocol says the rescue plan has to account for this, and it requires rescue within a non-negotiable window of 15 minutes.
15 minutes.
That is an incredibly tight time frame. What is happening in the body that makes those 15 minutes so critical?
Suspension trauma, or orthostatic intolerance, it's a silent killer. When you're suspended motionless in a harness, the leg straps can compress major veins.
Okay.
So blood pools in your legs, it
Mm.
can't get back to your heart and brain.
Yeah.
That lack of circulation leads to circulatory failure. It can cause kidney damage or even death very, very quickly.
So that 15-minute window isn't a guess.
No, it's the scientifically derived maximum time before severe, irreversible medical consequences start.
Yeah.
It just highlights that for some hazards, the rescue plan has to be practically instantaneous.
If we connect this to the bigger picture, I mean, look at the rules for confined spaces. The level of preparation seems almost excessive, but it's clearly necessary.
It is, because confined spaces tanks, pipelines, pits are classified as immediately dangerous to life and health. The protocol is so rigorous, it requires atmospheric testing before anyone goes in.
Checking for what?
Oxygen levels, toxic gas, flammable vapors, and then there has to be continuous monitoring the whole time someone is working in there.
And the human element is addressed too.
Absolutely. There must be an attendant, a spotter, stationed outside the space at all times with retrieval gear ready to go.
And their only job is to watch.
Their primary job is communication and monitoring. They are the eyes and ears for the rescue team. And the final critical rule is, never ever enter a confined space to try to rescue yourself unless you are a trained rescuer with the right gear. That attendant is there to call for help, not to become the next victim.
So as intense as all the moment-to-moment action is, the whole system really comes down to preparation, communication, and accountability.
Exactly. Before and after the event. And that communication has to be standardized so everyone acts without confusion. The protocol has 3 key siren signals everyone has to know instantly.
Okay, so you have the continuous siren. That's the universal signal for.
Evacuation required. Get out now.
Then the intermittent siren.
That means shelter in place. Stay inside, away from windows. Probably a chemical cloud or some other external hazard.
And finally, 3 short blasts.
That's the all clear.
Yeah.
And during an incident, they lock down radio use. You have to use the prefix emergency for any urgent traffic just to keep the channels clear for command.
And that level of clarity, it has to be maintained through constant practice.
Oh, yeah. The protocol mandates drills. It underscores that preparedness isn't a one-time thing. It's an ongoing action.
They require monthly fire drills. That's an incredibly high operational tempo.
It is intense, but you have to consider the risk profile.
Right.
High heat, flammable materials. That's necessary. And beyond that, they run medical emergency simulations quarterly and a full emergency response exercise biannually, where they test everything. Communications failure, coordinating with outside agencies, the works.
And attendance is mandatory.
Mandatory.
Right.
And they have to document improvements based on the drill results. They're constantly tweaking the blueprint based on reality, not just assumption.
And the system doesn't stop when the emergency is over. The document details this mandatory post-emergency accountability. You have to secure the area, preserve evidence, get witness statements.
Right, because the system has to learn from what just happened, and that leads directly into the investigation. Every single emergency has to be investigated by the safety team, and that includes a mandatory root cause analysis.
What's the difference between just, an incident report and a root cause analysis?
An incident report is the what. What happened, who was involved. The root cause analysis is the why. It's a systemic process. It's designed to look past the immediate cause, like a worker slipped, and find the underlying systemic failure, like there was no non-slip flooring protocol or the training didn't cover that specific hazard. The goal is to fix the system that allowed the incident to happen, not just blame a person.
And then all findings have to be implemented and communicated.
Yep, and the full incident report has to be done within 24 hours, and then they notify the regulatory authorities.
So what does this all mean? I mean, this deep dive into the Rhino Project's protocol, it wasn't just a list of rules. It was a masterclass in operational precision. We've seen the critical difference between the factory's permanent first aid room and the construction site's mobile units.
The precision needed for color-coded fire extinguishers.
And that terrifyingly tight 15-minute window for a suspension trauma rescue. The knowledge here is all about appreciating that the details, they are the execution plan.
And it all circles back to personal accountability, which the source material really stresses. Every single worker has to report hazards and near misses immediately.
Because a near miss is just data.
It's a data point waiting to be analyzed. And you never, under any circumstances, ignore an alarm. Critical thinking in a place like this means you're constantly questioning not just if a plan exists, but if it's ready and if you are ready to execute it perfectly.
The Rhino Project document requires mandatory annual refresher training or training after any extended absence. So here's something to think about. Given the extreme stress and complexity we've talked about, from chemical spills to electrical shutdowns, what crucial element of preparedness is the most likely to fail under that kind of pressure? And how does that mandated, documented refresher training specifically counter that known weakness in the human factor? That's something to mull over as you think about the preparedness plans in your own life and your own work.